Hi guys, this is Ms. Miner, and this is 12D, and we're going to be talking about today, we're going to talk about dilations. So this is kind of part 2 of dilations, and we want to understand that when I dilate an object, they are proportional to each other. They have a factor in common, and the factor that they have in common is the scale factor, right? And so we can use this idea of proportionality in order to set up some equal ratios to help us find missing side lengths. So that's what we're going to be working on today. Let's talk a little bit about the kinds of shapes that we see when we perform these transformations. When I do a translation or a reflection or a rotation, I don't change the size of the shape in any way. So what happens when I perform a translation, a rotation, or a reflection, the shapes that are made when I perform one of these transformations are congruent. They stay the same. And so if this side length were to be 3, then once I've performed my transformation, the side length is still 3, right? And so we have what are called congruent shapes when we perform these 3 types of transformations. The shape itself doesn't change size, the side lengths stay the same, and all the side lengths stay the same no matter what those side lengths are. Right? And angle sizes are the same in our shapes. And so we say that when we perform a translation, rotation, or reflection, the shape that's created when I perform that transformation is the same. It's congruent. However, when I perform a dilation, what happens is I have what are called similar shapes afterwards. And whether I'm going from big to little or from little to big, those shapes stay similar but proportional. And what that word proportional means is that they have a common factor. And the common factor that they have is the scale factor. And it's common to both. And so what that means is that, let's say my original size shape was this big one over here on the left. And its side length, this yellow side, right, was 6. Well, let's say this big shape was 2 times larger than the smaller shape. Well, if the scale factor here is 2, right, then this side that matches up with the yellow side to yellow side, right, would be a 3, because the common factor here is 2. 6 is 2 times bigger than 3. And so they are proportional to each other. And what that would mean is that if I perform my dilation, remember all of the sides have to stay within that same scale factor. And so let's say this side was 8, then the side length that matches up over here on this similar shape would have to be 4. That scale factor has to stay in common, even though one is bigger than the other, right? If this smaller shape, if the bigger shape is 2 times bigger than the smaller shape, then all the sides are going to continue to stay proportional to each other. If this side length over here is 10, then this side here would be 5. And so these 2 triangles are similar. They are proportional, and the common factor that they have is the scale factor. I hope you can kind of see what that means, that word proportional. So how does this help us? Well, let's just say in our minds, hey, I didn't know what that side length is. I knew the side lengths here, over here on the big triangle. I didn't know that one side on the small triangle. Well, I could figure it out. And the way that I would do that is there's a couple of different ways I could do it. I could first figure out what the scale factor was, right? I could take side length yellow from the big. I could set up a ratio. And remember the word ratio, let's put that in here as the word ratio is just a fraction. And what a ratio helps me do when things are proportional is it will help me figure out what the scale factor was. So let's say I didn't know what the scale factor was. I could figure that out by setting up a ratio of side length to side length. Because I know dilations are proportional, I can say, hey, the ratio of side length from the big triangle to the little triangle, right, would be 6:3. And then I just reduce that or divide it, right? 6 divided by 3 gives me my scale factor of 2. And so I can set up this ratio, I can find the scale factor, and then I can say, hey, what would give me that same, if I'm setting up big to little, right? What does X have to be if my scale factor is 2? And if my scale factor is 2, right, then I can just take 10, divide by 2, and that will give me X. So 10 divided by 2 would give me 5, and then I could figure out that my scale factor is, or my side length for my little is 5. That's one way that I could do it. Figure out the scale factor first, right? And then use that scale factor to help you find the missing side length. Another way of doing the same thing is setting up equal ratios. And equal ratios are something that you've probably been working on for a while. And so we're going to remind ourselves how to use equal ratios. And equal ratios mean that I take my big to little here, and I've decided to use big to little. I could have chosen to do little on top and big on bottom. Okay, it doesn't matter which way I set up my ratio. I just have to set up both of my ratios the same way. So I like to first determine how I'm going to set up my ratios. And I'm going to set up my ratios from the big triangle to the little triangle. So all my big triangle sides are going to be on top. So I'm going to choose side 6. And the matching little side to side 6 is 3. And I'm going to set that equal to my side length that I don't know. So big to little. And again, it doesn't matter how I set up my ratios as long as I do both of my ratios the same way. And so I decided to do big to little, and I could have chosen to do little to big. So it's up to you how you want to set up your ratios. When I set up equal ratios, the way that I solve for X is I cross multiply these sides. So 3 times 10 is going to give me 30 over here, and X times 6 is going to give me 6X over here. And now I just have a little equation that I have that I can use to solve for X. Divide 6 on both sides, that's going to cancel, and X is equal to 5. So either way, if I like figuring out what my scale factor is and then using that to help me find the missing side, that's cool. Or I could set up an equal ratio and solve for X by cross multiplying. All right, so there's a couple of different things here that we could ask as far as finding missing sides or figuring out if a shape is similar. Remember, let's start with just figuring out, are these two shapes similar or not? That's the question here. So on the left-hand side. The left-hand side is asking me, hey, are these two shapes similar? And remember, in a dilation, all sides remain proportional to each other based on the scale factor. So all the sides have to have these ratios that are equal to the scale factor. So each side, 6 over 3, has to be 2. right? And 10 over 5 has to be 2. And 8 over 4 gives me 2. So this is a proportional shape. And I can tell that it's proportional and that these two are in fact similar because each of the side lengths, when I set up my ratios, give me my scale factor. And so that's what we want to see in order to figure out if they're similar or not. So taking a look over here on the left-hand side, I've marked it with an L for left-hand side. Let's figure out if these triangles are in fact similar. And so what I like to do first is I like to figure out which is my big and which is my little. Here's my big triangle down here. Here's my little triangle up here. And I can tell because of the side lengths, right? And again, I usually set up big to little, but you could do it either way. Let's do little to big this time just to prove to ourselves that it works. Let's set up our ratios little to big. I want to check all of the sides. All of the sides have to be proportional in order for this shape to be similar. If they're not, then these are not similar triangles. So let's do little to big this time. And so I'm just going to pick a side. And so here, the side B to Q matches up with the side R to Q. So we're just going to take those two sides and I'm going to put little on top and I'm going to put big on bottom. And then I'm just going to divide these two numbers in my calculator and see what I get. It doesn't really matter what my scale factor is. I don't even know what it is. But I'm just going to do 22 divided by 121. And remember, any fraction is just a division problem. When I do that, I get 0.18. Okay, so far so good, right? Now I just go to the next side and I say, okay, B to C matches up with R to S. So now I check that one. Little to big is going to be 21 over 121. And I'm going to put that in my calculator and see what I get. 21 divided by 121 gives me 0.17. And I'm just rounding these off. But look at those two scale factors. Do they match up? No, they do not. So these are not similar figures. No, they are not similar. And so all the side lengths have to give me the same scale factor. Otherwise, they are not similar figures. Okay, missing sides. Again, there's a couple of different ways that I could do this. I could find out the scale factor first and then use scale factor to help me find the missing side length. I tend to use equal ratios and just cross multiply. I find that that is easier for me, so that's the method that I'm going to use most often here. So here we go. We are going to find the missing side length. Now what I want to do is I want to make sure that I'm matching up the right side with the right side. And so you can see here's my 37-degree angle. Okay, so I want to make sure that I'm matching up the right side here. So if you notice, then this side 80 matches up with this side. And I always want to look, maybe I might have some shapes, maybe this triangle, what if it was flipped this direction, right? And then my 37-degree angle would be over here. I want to make sure that I'm matching up the angle to the right place. So even if these were turned around or something like that, I just want to make sure that I'm matching up the side with the correct side. Okay, so this time let's do big to little. And so my big triangle is going to go on top of my ratio. My little triangle is going to go on the bottom. My big side length is 80. My little side length is 30. And that's going to be set equal to the other side that I'm looking at. So my big triangle, that one is the missing side. That's what I'm trying to figure out. On my little triangle, the side that matches up is 24. Okay, now all I have to do in order to solve this is cross multiply. So 30 times x is going to give me 30x. And 24 times 80, I'm just going to stick that in my calculator and get 1920. Okay, now here's my equation. I can just solve for x, divide 30 on both sides. These are going to cancel, and x is equal to 1920 divided by 30 gives me 64. So there is my missing side length over here. All right, so I can set up equal ratios of similar shapes in order to find the missing side length, or I could use the side lengths to help me determine if these two triangles are similar. All right, let's find the missing side length. So this picture is maybe a little bit like a eye challenge. It's hard to see what's happening here. What's happening here is I actually have two triangles that are laying right on top of each other. And the first triangle is on the bottom. It's the big triangle. So there's the big triangle. And then the second triangle is the little triangle that's laying right on top of the big triangle right there. And so these two are similar to each other because they share a matching angle. And so I can use their side lengths in order to find the missing side. I'm going to set up equal ratios. And again, I like to do big to little. Here's my big triangle. Here's my little triangle. And so I'm going to set up my ratios big to little. And I usually always kind of write out what I'm thinking so that as I go along, I don't get confused and I don't accidentally set up one of my ratios wrong. So I'm going to set up my ratios big to little. So my big side that I know is this big side that's 40 right here. And so this side length here is going to be 40. And then the other side length that matches up in the little triangle is the 32 over here. So 40 over 32 is going to be my first ratio. My second ratio is going to be over here. The big triangle is the missing side. That's the side I don't know. And then my little triangle, the matching side, would be 24. Now I'm just going to go ahead and solve this by cross multiplying. Over on this side, 32 times x gives me 32x, not 3x, 32x. And then 24 times 40 gives me 960. And now I have an equation. Once I cross multiply, this is just a small equation. One step equation. I solve for x, divide 32 on both sides. That's going to cancel. X is equal to 960 divided by 32, which gives me 30. And so the missing side length over here would be 30 then. All right, this time we are going to use the scale factor. It says, hey, use the scale factor in order to find the missing side length. So here's an opportunity for us to use the scale factor instead of use equal ratios, but we are actually going to use equal ratios to help us with scale factor this time. It's giving it to us written in a proportion instead of a ratio. So this is how a proportion is written, and a proportion can work either direction. So I could do A to B. A to B in this case is 1 to 2, or I could do B to A, which would be 2 to 1. I just have to decide which way I want to do it, but let's just do it the way that it's been given to us, A to B. So here's an easy way to use scale factor in order to find the missing side length. I'm going to use A to B. Okay, that's the way it's been given to me. And so my scale factor A to B would be 1 to 2. And I can write it here with the colon as a proportion, or I can write it as a ratio. The ratio would be 1/2. That means A is 1/2 the size of B. Do you see how that works? If I flipped it around the other way and did B to A, B is 2 times bigger than A. So I can work that back and forth either way, that scale factor. And that's what's kind of good about working as a proportion, right? So I can understand either direction. Okay, so I'm setting this up A to B. So A is 1/2 the size of B. And I can set that equal to my side length. Remember, I can use my scale factor to help me figure out the missing side length because they have that common factor. Okay, so my side length, A, is the missing side, and B, my side length is 6. So now I'm going to use cross multiplication in order to help me solve for the missing part. 2 times x gives me 2 x's over here, and 6 times 1 gives me 6 on this side, and then solve for x by dividing by 2. X is equal to 3. So there it is. Or I could have just started out by thinking, hey, what is 1/2 of 6, right? And so we can see now 1/2 of 6 would be 3. So either method, however I like to think about it, would work. All right, here it is again. A great idea would be pause the video at this point and see if you can set up your ratios and solve for the missing part. Then come back and check your work. Okay, hopefully you paused the video and tried it on your own. I'm going to quickly go through this one and make sure you got it. This one is set up A to B again, so we're going to set up our ratio A to B. And our ratio A to B is going to be 2 to 3, or 2/3, right? A is 2/3 the size of B. I'm going to set that equal to my side length. A to B, remember. So now I have to look at A first and say, hey, the side length here that's missing, right, is, I just call it X instead of question mark. And then the side length that matches over here is my 9. And so there is my equal ratios. Then I can solve this by cross multiplying. 3 times X is 3X. And 9 times 2 is 18. And there's my equation. I solve for X by dividing by 3 on both sides. So X is equal to 6. And now I know my missing side length. All right, here's some more practice problems to go over. They're a little bit different, but they work the same exact way. Let's go through a couple of these where I have a missing part of a side length, right? And so it says, hey, our scale factor A to B is 5 to 6. And we're going to set that equal to our missing side length. A is 30. B is 3X. So on these, I have to start to remember, hey, when I cross multiply over here, 6 times 30 gives me 180. But when I cross multiply over here, how do I do 5 times 3x? Well, 5 times 3x is going to give me 15 x's, right? Equals 180. Then I can go ahead and solve. Divide by 15 on both sides. That's going to cancel. And x is going to be equal to 12. So there I can again, now x is 12, right? My side length is not 12. So if it's asking for the actual side length, I've got to take my x, right, and put it back in here where x is. So I'm going to put it back in there, and I'm going to do 3 times 12. That means my side length here is 36. So there's a couple of things that could be asked from a question like this. They could say, hey, solve for x, the missing part, right? Or they could say, hey, what is the exact side length? And the exact side length here would be 36. Okay, let's try again down here. These are a little bit more involved equations that are getting set up here, right? And so, again, we're going to set up our scale factor, A to B. And our scale factor is 5 to 6. We're going to set that equal to our side lengths. Side length A here is 3x plus 11. And side length B over here is 42. So, again, we're going to solve with cross multiplication, but I have to remember now, how do I multiply 6 times 3x plus 11, right? 5 times 42 is going to give me 210. So I can do this multiplication. How do I multiply 6 by 3x plus 11? I got to reach back in my memory bank, back to the olden days when we were doing equations at the beginning of the year. And I have to remember that when I have a 6 and it's multiplying something that's being grouped together, and remember, whenever I create a fraction, this is a grouping symbol. And so these are being grouped together. They are one thing, right? And so what I want to do here is distribute that 6, multiply that 6 here, and multiply that 6 here. And so let's go ahead and do that. 210 is equal to 6 times 3, which gives me 18x, plus 6 times 11, which is 66. And now I've got my equation set up. I can solve for the missing part. Minus 66 from both sides. That's going to give me 18x over here. This is going to go away. And this is going to be 144 on this side. Divide by 18. That's going to go away. And x is equal to 144 divided by 18 gives me 8. Okay, so now I know the missing part. X is 8. But the side length, what I have to do is I have to take my x value now, and I have to go put it back in the original, right? The side length is 3 times x, which gives me 24 plus 11 is going to give me 35. The side length is 35. So all I did was I put that, let me erase I took 3x plus 11, and I put the 8 in for x. And so that gave me my 24 plus 11, which gave me my 35 up there. So there is my exact side length. Again, we could just ask for what the missing part was. We could also ask for the exact side length. And so you need to be prepared to be able to find both. All right, so this is the same kind of situation here. I think we've covered that ground well enough. If you have any questions for me or Mrs. Zeider, please make sure you're emailing us or coming to see us after school so we can get you any extra help or clarification that you need. Thanks, guys.